Happy Wednesday. I wanted to start off by saying how much I miss you all, and I can't wait until we're together again so you can all share your good news with me. I hope all of you are staying healthy as well as your families. So we've finished Unit 8, and now we're moving on to Unit 9, which is Systems of Linear Equations. There are 3 different methods to solve a system of linear equations. One is graphing, which we're going to do today. The next way is substitution, and the final way is elimination. So you'll see here there's a little bit of vocabulary. System of linear equations, 2 or more linear equations. Solutions of a system of a linear equation is the ordered pair that makes all the equations in the system true, the point of intersection. And in a minute, we'll look at 3 graphs and look at the different types of solutions. I forgot to say that if you were able to print out these guided notes, to go ahead and have those out and you can fill them in. If you did not have access to a printer, then you're probably going to want to write these out by hand as we go. So we've talked about the vocabulary. Let's look at the solutions to systems. You'll notice that in the first graph it says one solution. If you notice, it has one solution because the 2 lines are intersecting, and that point of intersection is at -2, 2, and that means one solution. What you'll notice about a system of equation that has one solution and intersects at one point is they will have different slopes as well as different intercepts. And that's different y-intercepts. I fixed my D. Okay. The next type of solution you might have when you graph is no solution. They're parallel lines. Well, what is true about the slopes of parallel lines? If you remember, you will have the same slope, but different y-intercepts. And in going back to this one over here for one solution, you could have different or the same. Because that means if you had for one solution the same intercept, that would be where your 2 lines would intersect at that point. And then finally, the third type of solution is infinite solutions. That means it's basically the same line on top of the same line, which means you would have the same slope and same y-intercept. Okay, so now you have a visual of all 3 of those. So we're going to look at the graphing method. So we learned a couple different ways to graph when we did graphing for linear equations and functions in the last unit. One way was to put it in slope-intercept form and graph using the y-intercept and slope. Also, another method, making a table and finding the points to plot. Or we use the cover-up method known as the x and y intercepts to solve as always. So the first step when we go to solve a system by graphing is to graph the lines. I personally like to put them in slope-intercept form because you can look at and see what the slopes of each are, and then you already know, are you going to have one solution, no solution, or infinite solutions? You then identify your solution after you graph. Okay, that's all that's on that page. So let's go to the next page where we're practicing solving by graphing. The first one, the system of equations is 2x minus y equals 8 and x plus y equals 1. So I'm going to take my 2x minus y equals 8 and put it in slope-intercept form. To do that, I'm going to subtract 2x, and I'm going to show it right below this one just to save a little bit of room. And I get negative y equals negative 2x plus 8. But I need positive y, so to do that, I'm going to either multiply or divide by a negative, and when I do, it switches the sign. So I get y equals 2x minus 8. In the next equation, I'm going to subtract x. And when I do that, excuse me, I get y equals negative x plus 1. So now I'm going to identify my slope and intercept of each. Of my pink line, my slope is m equals negative 1, and my intercept b equals 1. For my green line, my slope is 2, and my intercept is negative 8. So before I even go and graph these, I can tell by looking at my slope and intercept of each that they're different slopes and intercepts, so I should have one solution. These lines should intersect at one point. I'm going to start with the green one, and it's I'm going down to negative 8 on the y-axis, which is that very last point, and then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1. And notice I'm just doing this for a while because I want to then take my pink and I want to see where that intersection of those two lines is going to be before I actually draw my line. So for the pink line, I'm at 1 on my intercept, but I'm going down 1, right 1, down 1, right 1. And you'll notice I've now hit that point of intersection. So I'm going to draw my line. Remember that you have your IDs, which are a perfect way to draw really straight lines. And then I'm going to draw my green line. Get that a little more accurate. And I have now identified that my point of intersection is right here where I'm highlighting in yellow. And so it has one solution. And that solution is I'm going 3 over on my x and down 2 on my y. So it's an ordered pair, 3, negative 2. Okay, let's go to the next one. X minus 2y equals negative 6. In my top equation, to get y by itself, I'm going to subtract x. And when I do, I have negative 2y equals negative x minus 6. I'm going to divide by negative 2, and I get y equals 1/2 x plus 3. Then I'm going to go to the equation below that and make that one pink, and I'm going to subtract x, and I'm going to get negative 2y equals negative x plus 2, and then I'm going to divide by negative 2 all the way through. And this is going to give me y equals 1/2 x minus 1. I'm going to identify my slope as m equals 1/2 and my intercept as negative 1. For the blue line, I have the slope of 1/2, but an intercept of 3. So now I look, my slopes are the same, but my intercepts are different. That means I'm going to have parallel lines, which is no solution. I'll graph the blue one first. 1, 2, 3. From there I go up 1 over 2, up 1 over 2, down 1, left 2, and I draw my line. Go to my pink one, and I'm starting at negative 1 on my y-axis. I go up 1 over 2, up 1 over 2, down 1, left 2, and I draw my line. And we say that this is no solution. Now let's go to our third one. 2x plus 3y equals 6. I'm going to subtract 2x from that first equation, and I get 3y equals negative 2x plus 6. I'm going to divide by 3 all the way through, and I get y equals negative 2/3 x plus 2. In the bottom one, I'm going to subtract 4x. And I'm going to get 6y equals negative 4x plus 12. I'm going to divide by 6, divide by 6, divide by 6. When I do that, I get y equals negative 4 over 6 is equivalent to negative 2/3 x, and 12 over 6 is equivalent to 2. My slope is negative 2/3. My intercept is 2. In my green line, my slope is negative 2/3. My intercept is 2. When I look, I have the same line, same slope. This is going to be infinite solutions. I go to 2. On my y-axis, from there I go up 2. I can go up 2 and right 3. I can go down 2 and left 3. And I draw my line. So the green line and the blue line are the exact same line. So really, it's like you're drawing one line because the line would be on top of the other line. So this was infinite solutions. Okay, let's go to the next page. On the next page, these are some good practice problems for you. I do want to change one thing for you on this next page. I want you to change the second equation of number 1. I want you to make this y equals negative 2/3 x plus 5. Take away that 5/3. Okay? When you graph this one, you should end up with one solution. And it should be intersect at the point 3, 3. So you're going to try these on your own. This was number 1. Number 2, when you graph number 2, you're going to have 2x plus 2y equals 2 and x plus y equals 1. You're going to end up with the same slope and intercept. So this is going to be infinite solutions. Infinite solutions for number 2. And number 3, when you graph that one, you're going to have same slope, different intercepts. So you're going to have no solution. And it's going to be parallel lines. If when you graph you have trouble with these and you don't get what I have just told you, please message me and we can go through these together by messaging. So again, this one you should get in number 3, same slope, different intercept. And when you have number 2 in each of those in slope intercept form, you should have same slope and same y-intercept. Okay, so that's all there is to graphing systems of equations. 3 different types of solutions, and it's all based on looking at your slope and your y-intercept. Once you feel confident with this, feel free to start on the homework that I assigned for lesson 9.1.